Hello and welcome to the presentation of the planet Octonian. The planet is a rocky super-Earth that has been ejected from its parent solar system during its infancy and has gone rogue for the greater part of its existence. It has traveled through its original galaxy with an exomoon and has crossed the galaxy's frontiers to end its journey inside the nearest galaxy, while advancing toward a red dwarf planetless star. The Octonian star has captured the Octonian planet and its exomoon, thus becoming the adoptive star of a new solar system. The Octonian star is an M-type red dwarf with a mass of 0.152 times that of the Sun and an average density of about 156 times the Sun's density. Its diameter is 0.54 times the diameter of the Sun. The star is a flare star that sporadically undergoes dramatic increases in brightness due to magnetic activity. Its temperature is 3216 Kelvin and it has a luminosity of 0.00441. Its magnetic field is due to the star's convection process, and its flare activity gives a total X-ray emission that is like the Sun's activity. However, its conductive interior, which is due to the star's low mass, causes energy to transfer to the exterior by plasma movement rather than through radiative process. Therefore, the helium ash resulting from thermonuclear fusion of hydrogen circulates throughout the star instead of accumulating at its core. The star will consume practically all its fuel before the hydrogen fusion ends, which would be approximately 6 trillion years from now. The star is currently 88.808 billion years. The planet was situated at the edge of its original solar system during planetary system formation, when its protoplanetary body was ejected at the age of 20 million years and traveled from its original galaxy to its destination for a time of 3.61 billion years. It has been orbiting the Octonian star for a total of 5.83 billion years. The planet is currently 9.5 billion years. The planet orbits the star every 6,650 days, or 18 Earth years, at an average distance of 4.1 AU, which is similar to Jupiter's orbital distance in our solar system. A day on the planet is equivalent to 192 days on Earth. Octonian is 8 times Earth's mass, with a radius of 8.83 that of the Earth's. It has a high density and is qualified as a rocky planet with a surface gravity 2.5 times that on Earth. Here is a simulation of the planet's orbital period and radial velocity around its star. Notice the system period of 6,650 days. The increased mass of Octonian brings about internal pressures much greater than Earth's, which lead to large viscosities and high melting temperatures, meaning that its interior does not separate into rocky mantles and metallic cores like Earth does. The extreme pressures inside the planet creates liquid magnesium oxide, a liquid metal at its core, inner and outer, which helps create a protective magnetic field around the planet by generating a magnetic dynamo inside of it. Surrounding the core is a shell of water ice, a special type of ice that is only found at extremely high pressures. The mantle is primarily made of 70% silicon dioxide and 30% oxygen. The planet's crust is composed of 58% cobalt-2 chloride, 33% ferric iron, and 9% aluminum. The planet has a stagnant plate tectonic system where tectonic deformation occurred during the earliest geological phases of Octonian and gave rise to volcanoes, which are today dormant. This occurred when the planet initially left its solar system and experienced extreme temperatures, where the hot and cold stagnant lids tectonic deformation was driven by the cooling of the lithosphere. Lithosphere cooling from a hot start has led to thermal contraction and thermal stresses that generated tectonic deformation. The planet's volcanic activity is at an all-time dormant state where volcanoes periodically release water vapor. Each volcano has at its base multiple clusters of amethyst crystals due to the mantle and crust abundance of ferric iron and silicon dioxide. The surface of the planet is of a blue color wherever there is dry soil due to the cobalt chloride being in anhydrous state, and it is of a purple color where cobalt chloride comes in contact with acetic acid and becomes hexahydrate. Acetic acid is found in abundant large lake formations through the planet where asteroid impact craters formed when Octonian was rogue. Acetic acid is the most abundant solvent on the planet. Here is an artistic representation of the Earth's surface. During planetary system formation, as the Octonian protoplanetary body was being ejected from its original solar system, it received less of the stellar-generated ultraviolet light that can strip away the lighter elements of its atmosphere. Its own gravity prevented the escape of hydrogen and helium. During interstellar travel, the planet has sustained a thick atmosphere, which did not freeze out and was preserved by the pressure-induced far-infrared radiation opacity of its thick hydrogen-containing atmosphere. Because the planet has retained its satellite after ejection, it has benefited from significant geological tidal heating. The combination of a thick atmosphere and tidal heating has allowed the planet to maintain temperatures ranging from 8 to 48 degrees Celsius with an average of 28. When the planet began orbiting its star, organisms conducting photosynthesis using retinal emerged. With the help of the Octonian star light source, these organisms evolved to become purple vegetation that releases sulfur dioxide, nitrogen oxide, and methanol into the atmosphere due to anaerobic fermentation. This chemical combination produces acetic acid, which is released to the surface of the planet during large bounds of precipitation, given rise by purple lightning storms that occur frequently in the ionosphere. Here is a photograph of what these purple lightning storms would look like on the planet. Life on the planet began as electric bacteria with microbes capable of harvesting electrons from rocks and metals. These microbes produce hair-like filaments that act as wires, ferrying electrons back and forth between the cells and their environment. Over time, these bacteria evolved to exchange electricity between themselves and gained in intelligence. With enough time, about a few billion years, sentient beings came to life that consume electricity only and live in an 8-dimensional space. These electric beings self-replicate with thought and can induce electric variation in their generated offsprings through the analysis of their own existence. Here are representations of the electric bacteria form on the left and of the sentient beings on the right. Here are references used for this presentation as well as image credits. Thank you for listening to this presentation. Please feel free to ask questions and share comments.